Okay, guys, so today in class you did the first part of your homework set with your teacher, and we're going to continue on working with that tonight with a review of how we use our place value chart and how we use our measurement chart to help us do our conversions. So remember the steps for when you do conversions. You have to look at your problem. So our first problem here is 108 centimeters equals how many meters? So when they say 2, they're just basically saying 108 centimeters equals how many meters. So I use my place value chart and my measurement conversion chart to help me with this. So the first step is to write your number on your whiteboard or your place value chart on the other side. Then look at this chart for the units of measure. So my first step I'm going to do is, because it's 108, I'm going to write 108. Directly where it would fall on the place value chart. Now, when I'm looking at my units of measures on this chart, I'm going from centimeters to meters. So I'm going to find centimeters, or the centi, and I'm going to find the meter unit, because that's my main unit here, under meter. Now, my next direction is find how many columns you are moving and in which direction. So because I'm starting with centimeter and ending with meter, I'm going to the right from centi to meter, and I'm going 2 columns because from centi to meter is 2 jumps. So I went to the right 2 times. Now your third and final step is to flip back over to your whiteboard or place value chart and move your number to the same amount of columns in the same direction that you did for number 2. So I'm moving from centi to meter, so I'm going 2 columns to the right. So I'm going to take my 108 and I'm going to move it 2 columns to the right. So my 8 becomes from 8 to 8 hundredths, and my 100 becomes a 1. So I end up with 1.08. Now looking at this, I just did some math. I took 108 and I divided it by 100. And I know I divided it because I moved to the right and my number got smaller. And I know I divided it by 100 because I moved my numbers 2 columns to the right. So what they want us to do here is, instead of writing 108 divided by 100, they want us to write it in exponential form, right? They say with an exponent, and they give us an example. So remember from last week that we learned that I can rewrite 100 as 108 divided by 10 to the second power, because there's 2 zeros. Now, my final answer equals 1.08. So I'm just kind of using this to write my equation. 108 divided by 10 to the second power equals, and I'm a little out of room, 1.08 or 1.08 meters. Now, this makes sense as well if we think about our meter strip that they mention here. A meter strip is basically you thinking about that if this represents a meter, 1 meter is made up of 100 centimeters. So if each one of these little boxes is worth 1 centimeter, I would have to draw 100 of them to equal 1 meter. So I'm using that same information here, where I'm thinking that 100 centimeters is going to give me 1 meter. So I'm going to end up with a partial meter left over, which is my 0.08. But I'm using my place value chart and my measurement chart to make that a little more straightforward for my math. So you're going to use your place value chart and your measurement chart to do this. So let's keep practicing. 50 centimeters equals how many meters? So I'm going to follow the same steps. Write 50 on my place value chart, because 50 is my number. Now I'm going from centimeters to meters, so I'm going to look over at my measurements, find centimeters, find meters, and look, okay, from centi to meter, again, it's actually the same conversion. I'm going 2 columns to the right. So I'm going to move my number 2 columns to the right. So I end up with 0.50, or 0.5 because this extra 0 is a superfluous 0, as my answer. So 50 centimeters equals 0.5 meters. And I'm going to prove that here with my equation. So I did 50 and I divided it by, and again, I know I divided because I'm going from centimeters to meters. I'm going from a small unit to a bigger unit, and I divided by 100 because I moved to the right. So 50 divided by 100, or 50 divided by 10 to the second power equals 0.5. Remember that it's 10 to the second power because there are 2 zeros in my 100. My 100 is made up of 10 times 10, so I get that 2 in my exponent. So the pattern is going to keep going, and we're using our place value chart understanding to finish this up. 6.3 meters equals how many centimeters? Okay, so I wrote 6.3. I look at my chart, meters and centimeters. This time I'm going from meters to centimeters. So I'm still moving 2 columns, but now I'm moving 2 columns to the left. So when I take my 6.3, I'm going to move 2 columns to the left. 1, 2, and I fill that in with a 0. So I get 630. So I get 6.3 meters equals 630 centimeters, which makes sense because I know there's 100 centimeters in each one of these meters. So it has to be at least 600 because there's 6 whole meters. So I have 6 whole meter sticks. So I did 6.3, and because I'm now moving to the left, I'm timesing by 100, because again, there's 100 centimeters in a meter, which I can write exponentially as 6.3 times 10 to the second power, 630. So we're basically following the same pattern, using our place value understanding over and over again. Now, number 2 is basically the same concept, but now notice that we're getting and going beyond centimeters. So now we're in millimeters. Now, thinking about your meter strip, you would think about it in the exact same way, but now instead of 100 centimeters, we have to think that that prefix milli means 1,000. So there's 1,000 milliliters now in every meter. So instead of having 100, I'm going to have 1,000 boxes. So 4 on my place value chart, because I'm going 4 meters. I'm going to find meters. I'm going to find millimeters, because I'm going from meters to millimeters. I'm going to the left, so I'm going to be multiplying, and I'm going to go 1, 2, 3, so I'm multiplying it in 3 columns. 1, 2, 3. Fill in those empty places with zeros, and I get 4,000, which makes our logical sense, right? Because there's 1,000 milliliters in every meter. So if I have 4 meter sticks, I'm going to have 4,000 millimeters. So I have 4 meters equals 4,000 milliliters. And the math I did was 4 times, because I'm going to the left, I'm getting a bigger number, and I'm timesing it by 1,000, which again, I'm going to write it exponentially. So 4 times 10 to the third power. Let's try that one more time. Now I have 1,050 milliliters. So 1,050 milliliters, and I'm going to meters. So again, milli and meter are my units, but now I'm starting at milli and I'm going to the right till I get to meters. So because I'm going to the right, that means I'm going to divide, and it's 1, 2, 3 columns. So I'm going to go 1, 2, 3 and fill in. Right, 1, 2, 3, yeah. So I get 1.050. So 1,050 millimeters equals 1.050 meters, which again, we can stop and make some logical decisions here. If I have a little over 1,000 millimeters and I know 1,000 milliliters is going to equal 1 meter, then I know I'm going to have at least 1 with a little bit of extra. So it makes sense. Thinking about the equation we did 1,050 and we divided, because we went to the right, by 1,000. And I know it's 1,000 because it's 4 jumps, which is another way of saying divided by 10 to the third power, because it's 1, 2, 3 zeros, so it's 10 to the third power. Let's do a quick try at a word problem. So the word problem says Yiting's height is 1.49 meters Express this measurement in millimeters. Explain your thinking. Include an equation with an exponent in your explanation. So let's first do our conversion. We're starting with 1.49 meters. So I wrote that on my chart. I'm going from meters to milliliters, which we should know, but at this point, flip back. Meters to milliliters. It's 3 columns to the left. I'm multiplying it. I'm making it a bigger number because millimeters are way smaller than meters, so I'm going to get a lot more of them. And I'm moving it 3 columns. So 1, 2, 3, timesing it by 1,000. 9, and fill in that 0. So if we think of the fact that 1.49 meters equals how many millimeters, which is what this question is asking us, we can show our equation, which they asked for, and say, okay, well, there's 1,000 millimeters in 1 meter. So we did 1.49 times 1,000, not 10,000. They want an exponent, though, so I'm going to rewrite that as 1.49 times 10 to the 3rd power, which is going to give me my final answer that we found over here of 1,490. And because it's in millimeters, we need to make sure that we wrote millimeters as our final answer. Now, we always finish and answer our questions with answer statements. So we can write Yi Ting measures 1,490 millimeters. And I explained my thinking mathematically with numbers. Last one, a ladybug's length measures 2 centimeters. Express this measurement in meters. Explain your thinking, include an equation with an exponent. Okay, so virtually the same thing. 2 goes on the place value chart. I'm going from 2 centimeters to meters. So I need to look at centimeters and meters. Centimeter. I'm moving 2 columns to the right. So that means I'm dividing. 2, 1, 2. Fill in our empty holes with some zeros, and we get 2 hundredths. So let's show our work with our equations. The 2 centimeters, we are dividing because I moved to the right, and I moved 2 hops, so that's dividing by 100. But again, it wants it in exponents, so 2 divided by 10 to the 2nd power, and we got 0.02 meters. And that again makes sense, our logical math checking. If I have 2 centimeters are very small, and a meter is a much bigger unit of measure. So 2 centimeters to convert to meters is going to be a really small part of my meter stick. So the ladybug measures 0.02 meters. So that's all for tonight's math homework. Hopefully we're getting a little more familiar with how we use our place value charts and how we use our measurement conversion chart to help us relate the 2 concepts and be able to see that it's not that tricky as long as we're learning how we hop and in which direction. The big thing is remembering to express ourselves in our equation, because it's more than just understanding the hopping. It's relating that to the equation, because eventually we're going to stop using this and you're just going to be expected to do this. So make sure that you're practicing going back and forth and using all your resources that you have, and we will do a little more discussion on this concept tomorrow.